identifying potential hazardous tools and operations. This is not always obvious. For example, a water pressure jet used to clear drains, you think, well, that's not a vibration problem. If you put it in pulse mode, you've got about 15 minutes use per day. So there are certain weird things or combinations of things that can cause problems. And it always takes, people ring up and say, we need a risk assessment done, and you say, well, we need a list of your tools in detail, and they say, oh, I'll get back to you next week. No, they won't. It'll be 3 or 4 months. People always underestimate the number of tools they have. Our current record holder is in South Wales. They said we've got about 100 tools. Currently, they're on 600 and still rising. So this does take time. Then you have to assess the risks, and how do you do that? And I'm just going to talk about the basic mistakes that people make. Training is really important because personal behavior, unlike most risks, has a big effect on your actual risk. And we have risk reduction programs by HAVS. I'll just touch on surveillance. One of the key first elements is a vibration management program is risk assessment. Now, there's a whole industry predicated on measurement. Measure, 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 measure. Placebo measurements. The problem is, you know you've got a problem, so you spend a lot of money every year remeasuring your problem, which says you still have a problem. It's exactly this big this year. It doesn't get you any further forward. But it's harder to do something about it. So you're looking at tasks and activities. You make a big list of them, and you then try and get a tool register. Off the record, this bit's off the record. It's hard to get tool registers because there's a load of tools you don't know about in cupboards that get used once a month or something for particular jobs. So there's something you can do is spread a rumor that unless a tool is on the register, if you're going to put in a claim in the future, you can't claim. Then people are running after you with tools. You've got to try and get this list of tools, and it does take a long time. And what you need is details of how the tool is used, the materials it's used on. You want to know the make and model. Something called blue drill doesn't cut it. You know, okay, it's a drill and it's blue, but it doesn't actually tell you much about it as a piece of kit. So you're building up this tool register, and that is going to be the final, if you like, you need a list of tools that are acceptable within your industry, within your company, and you're not allowed to use any tools that aren't on this list. Vibration data. Have any of you measured hand-arm vibration? Handful of you. How did you find it? Very?
Subjective, depending on your pressure to operate or whatever.
Very subjective. It's also a pain. It's, you know, in our office, when a hand-on vibration job comes in, no one wants to do it, to actually do a measurement. It's time-consuming to do it properly, but unfortunately, the only way to get accurate data is to do it properly. Now, in the UK, the guidance from the HSE actually states, do not measure unless you have to. Get vibration data from reputable sources, field data as used in the field, in the sort of operation that you're doing, and do the minimum number of measurements, because you spend all your time and resources measuring and monitoring rather than on risk reduction. The other part of it is you've got vibration data to acquire off databases and so on. The other part is trigger times. It's how long you squeeze the trigger. If you say to somebody, how long do you use that angle grinder for? They're going to say 2 hours a day. Well, the finger on trigger time, people go, oh my God, 2 hours a day, he's well over the limit. But he's actually squeezing the trigger perhaps for half an hour a day. So you need to do that. And the way you do that is with very simple, there's tool timers around, cheap tool timers and so on that you can use. So you're assessing, what you're trying to do is to say, what is the dose per task? You're trying to acquire data that you can reuse. So if someone's doing up nuts on a wheel and they change the number of nuts, don't have to remeasure. You just multiply it up so you can assess from your existing data. The whole aim is once you get a really good set of data, you get a range of values for that particular job. Every time you measure, you're going to get a different answer. The actual regulatory levels are finger in the wind. They're not that accurate. So you're trying to get enough data, and once you've got a good risk assessment, then you never have to repeat it. Now, hand-arm vibration measurements are expensive. You're actually going to physically measure. It's costly, it's time-consuming. Our rule of thumb is you can probably do 20 tools in a day if everything goes really, really well. Because it just takes a long time to do it. You have to arrange to get the tools there. You have to arrange for something to work on. If you're testing a load of breakers, for example, you need something to break. And the stores in which the breakers are held, they don't want you digging up their floor. So you have to find bits of concrete or go somewhere else and dig up someone else's floor. So the aim is to spend the minimum on assessment and the maximum on risk reduction. Just a quick technical aside here. If you double the vibration, you double the risk. But it requires 4 times the finger on trigger time to double the risk. So in other words, it's more important to have accurate vibration data than finger on trigger time. People get hung up, oh, it's 23 minutes, no, I think it's 18 minutes. It doesn't matter. It matters if it's 1 hour or 3 hours, but if it's a few minutes or 15 minutes out, it just doesn't matter. So measuring vibration is has to be slightly more accurate than measuring finger on trigger time. To the international standard measurement is you rigidly attach the accelerometer to the handle. And that's what all the risk statistics were done, based on data. I'm old enough to have supplied some of this data on which risk statistics are done. You rigidly attach with a band clamp or a cable tie really, really tightly so it's absolutely immovable on the handle. That gives you a fairly repeatable measurement. You're still going to get a range of values. You cannot use things like hand-gripped accelerometers. I mean, I think that's probably what you're referring to, how tightly you grip it. They give you the wrong answer. A couple of examples here. On a grinder with a fixed accelerometer 2.2 meters with a handheld one 0.8 to 1.8. So between half and almost the right answer. On a high impact tool, we've got 18 measured correctly, 9.5 measured with a handheld accelerometer. And it depends how tightly you grip it. If you get a different answer with the way you're measuring compared with a hard-mounted accelerometer, your answer is wrong by definition because you can't compare it to the risk statistics. It's not to say at some time in the future they won't be able to invent a better way of measuring, but you have to spend years and years and years correlating it with the risk. Now, there are loads of new kit coming out with new accelerometers, new electronics, and all the rest of it, and this is confusing. And some of the wording used is confusing. Handheld transducers, which is a very common one, glove-mounted transducers or wrist-mounted transducers. And you get the impression from a lot of the literature that this saves time and effort and all the rest of it. In most of the literature, it does state that it doesn't comply with the standard. But a lot of end users are confused by this and assume it does comply with the standard. And you can underestimate someone's risk by a factor of 2 or 3 or 4 if you do that. So this is a big problem because of the technicalities of measuring vibration. So you have to be very, very careful. And to show you a few examples, if you read these and you're not a vibration expert, vibration measures vibration in hands, sensor attached to a special glove, everything you need for easy and accurate hand-on vibration measurement. Now, you'd assume that gives you the data you need. Unfortunately, it gives you the wrong answer compared with the standard. A wearable monitor records the vibration on the wrist. Now, again, that's even worse because, you know, if I undo my watch and let it slide like this, it's going to give me a totally different answer than if I tighten it up. Personal daily vibration dose, complying with all these standards. The equipment complies with all these standards, but these aren't hand-on vibration measurement standards. They're instrumentation standards. The measurement does not comply. It can do with a special adapter, which you clamp onto the handle. And we get consultancies. We had a course a few years ago, a local authority guy has his head in his hands because they get all their kit measured every year by a consultancy who strap the accelerometer on with masking tape, which is, you know, I said, sue them because you're underestimating the risks. So they're saying they use the latest gloves to measure vibration and triaxial accelerometer and so on, testing to the international standard, but the glove data is not to that standard. This is disingenuous and will seriously underestimate. And they don't use spell checkers. Maybe I'm nerdy, but I think that's quite important on a technical document on the web.